Welcome to our sixth video in which we're looking at the intersection of two planes. I wonder if you can spot which of these planes are parallel. Yes, you probably noticed. I forgot to cover up the answer. Pi 1 and pi 2 are parallel. Why? Because the normal vector here is 2, 5, 1 and here it's 4, 10, 2, which are scalar multiples of each other. So those are parallel. If the normal vectors are parallel, then the planes must be parallel. Pi 3 is parallel to neither of these because you can't make 1, 5, 3 a scalar multiple of either of these. We're going to find the equation of the intersection of pi 1 and pi 3. So because we know those are not parallel planes, then they must meet in a line. Now it's pretty easy. It goes back to chapter 3 when we're solving systems of equations. We have this system, and the idea is firstly to eliminate y, write z in terms of x, and then start over again, eliminate x and write z in terms of y. You could try that just now. Pause the video for a moment. And here's what you get. So down here I've eliminated x and written z in terms of y, and here I guess I've missed out some steps. I've eliminated y and written z in terms of x. Try and fill in the steps for yourself. Because this is z and because this is z, then these three ratios are equal. We've got the Cartesian form of the line, which we can then write in vector form, and now we've got the direction vector of the line and the fixed point. So if I go to my autograph sketch, I've got the two planes there. You can see they're not parallel and that they meet in a line. And if I enter the equation of the line, which was 8 minus 6 over 5, 0, 2 minus 1, 1. Okay, there's the line of intersection right there. Cool. Now, interestingly, if you were to type that system into your calculator, it actually tells you the equation of the line. Only instead of lambda or t or whatever our parameter is, it uses c1 as a default. And if you look really closely at this, you will see it's telling you the x coordinate is 2 times the parameter plus 8. That's what this is. The y coordinate is minus the parameter, subtract 6 over 5, which is what this is. And the z coordinate is just the parameter. It's the same thing. So your calculator is pretty useful. And notice that's an infinite set of solutions, as opposed to no solutions found, which we'll see in another video. So here's a task for you. Now find the equation of the line 2, the intersection of pi 2 and pi 3. Have you any predictions of the relationship between line 2 and line 1? Remember, line 1 was the intersection of pi 1 and pi 3. Try that. Pause the video. Here's the answer. Same idea as before. You eliminate x, write everything uh, in terms of y, z in terms of y, and then here eliminate y, write z in terms of x, and then put the three together to make the Cartesian form and then the vector form. And what's the relationship between this and the previous one? Yeah, it's parallel. So if I go back to my figure and add the next plane, 4x plus 10y plus 2z equals 10. That's the third plane. And we've just worked out this equation, which was 3 minus 0.20, and then 2 minus 1, 1. What's the relationship between the two lines? I'm sure you figured it out. They're parallel. Okay, and it looks something like that. So pi 1 is parallel to pi 2, and pi 3 is kind of a transversal plane, and the two lines L1 and L2 are parallel. Great, you are now ready to do these ones for homework.